Alright, this tutorial will help you to write algebraic equations for examples that show angles. Now we're going to go back and review some 7th grade material here with complementary, supplementary, and equal angles. So if you're following along in your notes, write this in the table of contents and write down the appropriate page number. So again, we're going to revisit a 7th grade standard here of finding the measure of a missing angle by writing an equation for their given relationship. And there's only 3 relationships that we can work with: complementary, supplementary, and equal angles. So hopefully you remember these vocabulary words. To complement someone is the right thing to do. So that's a 90-degree angle. Some people also know it as this trick. Complementary starts with a C. Did you see that? C. And I turn it into a 90. Supplementary is 180 degrees, right? Supplementary is 180 degrees. Complementary is 90 degrees. And equal angles mean they are the same. So the second thing you need to be able to do to be successful today is to write an algebraic equation after choosing the correct relationship. And then the third is to solve for your unknown variable and substitute that value in to find any missing angle measures. Alright, so let's take a look at some of the vocabulary you need to be familiar with when you're learning about angles in algebra. The first thing you need to know is that an angle is formed by 2 rays, right? I have a ray here with an endpoint and an arrow, another ray here with an endpoint and an arrow. A ray is always named by starting with its vertex, right? Starting with its endpoint, and then whatever value or other letter it passes through, that will give it its name, right? So those rays are called the sides. One side is called ray BC, written like this, and the other side is called ray BA. It's written like this. So the symbol for an angle looks kind of like a less than sign, but it's a little more flat at the bottom, right? This is like a less than sign, and the angle sign is really flat along the bottom edge there. When you name an angle, you typically use 3 letters, and the middle letter should always be your vertex, right? So we can call this angle B. We could also call it by all 3 of the letters it passes through, A, B, C, or we can even call it the reverse, C, B, A. But those are the only combinations. You can't call it angle C, A, B because they don't connect in that order. Alright, another symbol that we use is this little M, and sometimes it looks like a cursive M like this. And when we put it in front of an angle sign, it stands for the measure or the size. So if I were to say M angle ABC, I'm talking about the measure of angle ABC. And as you can see here, the measure is 60 degrees. Alright, some other things we need to review are what types of angles can you have. So these are your only choices today when we're writing our equations. You will be talking about acute or less than 90-degree angles, obtuse or greater than 90-degree angles, right, equal to exactly 90 degrees, or straight angles. They make that 180-degree straight line. So remember, you can name an angle by just calling it by its vertex letter, but when you're naming the sides, be sure to use the ray symbol, not the segment symbol, not the line symbol, and not no symbol at all. So be careful. Angle K is made up of rays KJ and KL. Angle JKL can be named in 3 ways, just by the vertex or with the reverse of the 3 letters it passes through. This particular angle happens to be larger than 90 degrees, so that's an obtuse angle. In example 2 here, we have our vertex, which is R, And we have our rays, RS and RQ. And don't forget you can name it 3 different ways. This angle has a little box in the middle. That's our perfect 90-degree angle. And anytime you see that box, you know it is a right angle. If you do not see this box, you cannot assume, even if it looks like the most perfect corner, you cannot assume it's 90 degrees unless that box is there. Alright, now for the hard part. When you have relationships between angles, they can either be equal to each other, like our first example here. So vertical angles are 2 angles that are opposite of each other. So 2 and 4 are opposite of each other, and they touch at the vertex. So that's why they're vertical angles. Angle 1 and 3 are also opposite of each other, so they are also vertical angles. But notice the difference in the size of my marks. Do you see how long my red curves are? And that's because 2 and 4 are obtuse, and 1 and 3 are acute, right? So 1 and 3 are equal to each other. And if I asked you to find the measure and you said, oh, 150 degrees, your common sense should tell you that's not right. So opposite angles that touch at the vertex are always equal to each other. So in this example, angle 1 is equal to angle 3, and angle 2 is equal to angle 4. In our second example here, we have a perfectly right angle. And a perfectly right angle can be split into 2 angles, or 3 angles, or 4 angles, or 5 angles. But if I have just this situation, which I have on the screen, then I can say that angle 7 plus angle 8 would make 90 degrees. Because the sum of 2 complementary angles is always 90 degrees. And in my third example, I have an acute angle adjacent to an obtuse angle, and when I mark them side by side, I get that 180-degree curve. And that's because the sum of supplementary angles is always 180 degrees. So you could say that angle 9 plus angle 10 sums to 180 degrees. Remember, complementary and supplementary angles do not have to actually be adjacent to each other, right? They don't have to be touching each other. If I told you I have an angle that's 60, and over here I have an angle that's 30, you could still tell me that they are complementary, even though they're not touching, because they sum to 90. 60 plus 30 sum to 90. Right, remember, adjacent angles have a common vertex and they share a common ray. So angle 5 and angle 6 are adjacent to each other because they share a common side. Alright, so let's see if you can name these pairs of angles. So I want you to use all of the words that might apply here, right? So are they a pair of right angles? Are they a pair of complementary angles? Are they a pair of supplementary angles? Are they a pair of vertical angles? Are they a pair of adjacent angles? So go ahead and pause the video and give it a try. Alright, let's take a look and see how you did. So example number 1. Those 2 angles make a right pair, they are adjacent, and they're also complementary. Number 2, they don't have any special size relationship. 1 happens to be acute, 2 happens to be obtuse, but it does not make a perfectly straight line, so they have no other relationship. Look at number 3. If I trace angle 1 and then I trace along angle 2, do you see how I touch the same straight line? That's how I know they're supplementary. And with number 4, they share a vertex and they're opposite of each other. So that makes them vertical, equal angles. Alright, let's get started. These are the 3 skeletons of what you're going to be using today. You have to choose one of these relationships for any question that I give. If you have two vertical angles, you would put the algebra for one on this side, the algebra for one on the other side, and you would solve for x. If they were complementary, your two angles would go on the same side with a plus sign in the middle. On the right side, you would have a sum of 90. The same setup applies for supplementary as complementary, but notice the solutions. They're completely different. So let's get started. Number 13, I have to ask myself, are they equal, are they complementary, or are they supplementary, right? Are they equal? That's my setup. Are they complementary? That's my setup. Are they supplementary? That's my setup. So for number 1, these two angles are equal. So I put an equal sign in the middle, my algebra 1 on the left, my second if it's algebra on the right, and if I need to isolate anybody, I do. But in this case, I was done pretty fast. Number 14, you see that box? You know what that means, right? That's a right angle. And right angle with two separate angles included are complementary. So again, I put my first measure here, I put my second measure there, and in this case, I'd need to do some math. So use your calculator to help you out with this. So my missing angle measure is 19 degrees. Number 15. These two angles are adjacent, but my only choices are equal, complementary, or supplementary. And it looks like when I trace my angles, they both touch the same straight line. And straight line angles have a sum of 180. Again, I put the expression for one of the angles here and the other angle there. So minus 142 minus 142, x is equal to 38 degrees. Alright, question number 16 has 3 different letters in it. That's odd. But I do know that letter y is across from 54 degrees. So that means that y and 54 are equal because they're vertical. Now let's see if I can find x and z. Well, the good news is x and z are also vertical. So I know that x is equal to z. Problem is, I need to know what x and z are. So even though x and z are vertical, I can't have two letters at the same time in my equation. So I'm going to have to use this 54 somehow. And 54 and x have a relationship. Do you see it? When I trace 54 and I trace x, when I start and finish, I touch the same straight line. So these two are supplementary. So I subtract 54, subtract 54, and now I'm going to get my answer for x. So x is equal to 126. And since x and z are equal, then I don't even have to do any math here. That's 126 as well. Alright, let's try these last two. Question number 17. Given that the measure of angle RST, so that's from here all the way to there, that whole thing is 112. So what's the measure of x? Well, if from here to there is 112, then from here to there is whatever 87 and x are. So 87 and x equals 112. So we subtract 87 on both sides here. And let's see what we're going to get. 12, 13, 14, 15, 25. So x is 25. Alright, last one. Looks like I've got 3 angles here. But when I start and finish, They're all along the same line. So 51 plus 18 plus x is equal to 180. So 51 plus 18 is 69 plus x equals 180. Subtract these from both sides. 111. So x is 111 degrees. Are you starting to get the hang of it? Alright, let's try a few more. These two are vertical. So that means I'm going to put one algebra sentence on the left, an equal sign in the middle, and one algebra sentence on the right. So 8x plus 31 equals 16x minus 9. So I'm going to subtract 8x from both sides. I'm going to get 31 is equal to 8x minus 9. I'm going to add 9 to both sides. I'm going to get 40 is equal to 8x. And now when I divide by 8, I'm going to get x is equal to 5. So I did a lot of math here. Let me shrink this down so it fits in this box. Now I found what the measure of x is, but if it asked me to find what the measure of the angles are, I'd have to go a little bit further. Now this example doesn't ask for that. It just says find the value of x. But if I wanted to know what the measure is, I would remove the letter x and I would replace it with the number I found. So 8 times 5 is 40. 40 plus 31 is 71. So if I wanted to, I could say that these two angles are 71 degrees. But my directions don't ask for that, so I'm not going to do that here today. Alright, let's keep going. These two are supplementary. So they belong on the same side of the equal sign, with a plus sign in the middle, because they add up to 180. Combine like terms. Combine like terms again. And now let's solve for x. Again, I'm going to group this together. I'm going to shrink it down so it fits in this box. Whoa, that was crazy. Alright, pause the video and see if you can try these two on your own. These two are complementary. So they belong on the same side with a plus sign in the middle. I'm going to skip some steps here. Minus 13, minus 13. How'd you do on the last one? These two are supplementary. So they belong on the same side with a plus sign in the middle. Combine like terms. Is that right? 10x plus x is 11. Negative 13 and 6 is negative 7. Oh, plus 7. I made a mistake here. That's right. 11x equals 187. So this goes in 1 time, 17 times. Alright, you getting the hang of it? Alright, pause the video and try these 4 on your own. Alright, now notice that this time I asked you to find each angle measure. So let's take a look at my answers. Pause the video and look at all of my work, from the setup, to the solution, to the plugging it in, to finding the actual answers. So take your time and really look this over. Alright, I'm going to move on to some other word problems now. And this is the last three. Angles R and S are complementary angles. If it helps you to sketch that out, then you should draw something like this. Angles R and S are complementary angles. The measure of angle R is 2x plus 7. The measure of angle S is 4x minus 13. If you feel like you need to take notes, you could certainly draw them like this and label. But as soon as you see complementary, the first thing I want you to do is write an equals 90 on your paper. And then you just take the two algebra sentence and you add them together. Combining like terms, using inverse operations, so plus 6 plus 6. I don't have a lot of space, so I'm going to skip writing it. Divide by 6, divide by 6. And then it says find the measure of angle R, and that's not what this says. This says that x is 16. So if I want to find the measure of angle R, which is 2x plus 7, I'm going to take my x away, and I'm going to replace it with a 16. So the measure of angle R is equal to 32 plus 7, which is 39 degrees. Alright, number 13. Angles 1 and 2 are vertical. Do you remember what that means? Vertical angles are equal to each other. So the equal sign has to go in the middle, and one angle goes on each side. So minus 5x from both sides. Subtract 1 from both sides. And then divide by 2. I'm going to come up here because I ran out of room. But remember, they want the angle of measure 2, not the missing x. So if x is 23, then that means the measure of angle 2, which is this, is 5 times 23 plus 47. So let's see, that's 115 plus 47. So that is 163 degrees. Alright, last one. C and D are supplementary. That means that their sum is equal to 180 degrees. So I'm going to add these two angles together. And I'm going to say that they're equal to 180. Combine like terms. Subtract 12. I've run out of room, so I'm going to move up here. And divide by 28. Okay. I don't have my calculator here, so I'm going to take a guess that maybe it's going to be 6. 28 times 6 is 48. 12, 13, 14, 15, 16. Yes. All right. So the answer is x is 6. But again, that's not the question. The question is, what's the measure of angle C? Well, C is 12 times x, take away 7. So I'm going to fill that x in here. So 72 minus 7. Measure of angle 2 is 65 degrees. Alright, here's your exit ticket. Turn this in to me to get credit for watching this lesson. Pause the video to write it down, and good luck.